Wait, is this supposed to be a part of today's do now that we're supposed to turn in?
Yes.
Oh, I'll just do it and put this with it.
Yeah, it only went up first period because when I put that assignment up, I just make it for all 4 classes at once because every class that I'm running has a weekly warm-up.
Oh, okay.
Okay, welcome in, y'all. Happy Friday. I'm not going to take attendance until 40 after just because I was a little late getting it up. AP Physics went a little bit long because I had a lot of questions about the last lab that we did. I did the whole lab from home, man. I did it in the office behind me, recorded it, posted it online, and then I also posted the data set online, as an Excel sheet. It was wacky, but it kind of worked out. I'm pretty glad I was still able to keep the lab stuff going from home. Nonetheless, here's what I got going for y'all today. I really just have a 1-part warm-up. Number 1, a rectangle has coordinates -3, 5, 3, 7, 0, -4, and 6, -2. I would like you to reduce the coordinates of this rectangle by a factor of 1/3. Graph both the original rectangle and the new coordinates in Desmos, and then show the scale factor by the distance formula. Is there anybody out there who's never used Desmos?
Me.
Me too.
Okay. So let me, since we're all, doing education from home, let me show y'all Desmos and its power. It is hands down my favorite piece of software for graphing, period. It's just amazing. So let me share my screen with y'all. So you want to go to desmos.com, or you want to install the Desmos app. And Desmos looks like this. Y'all can see me sharing my window, yeah?
Yeah.
Okay. So let's say that I'm graphing, for example, a line, right? Y is equal to 1/2 x plus 5. So this is a line where 5 is my intercept, and then I count the slope out. I go up 1/2. This is another point on the line. And Desmos knows that, and it can just generate all of the points for the graph forever. Desmos also knows how to graph inequalities. What happens when we graph an inequality? Kids from Algebra 1, what happens when you graph an inequality? Hello? Did I disconnect?
No, I just don't know. I can hear you.
Oh.
I don't know about anyone else.
When you graph an inequality, you shade. So if I replace this with an inequality, this is telling me that from the line I should shade up. And again, Desmos knows how to do that. The nice thing about Desmos is it has all the functions in it. So what's the shape of a graph of the form x squared?
Parabola.
A curve.
Y is equal to 3x, specifically a parabola. A curve is a general term, plus x plus 5 or whatever. It can take that and graph it. And here's what's even better than having it just graph a parabola. You can also have Desmos graph things with sliders. So I can say y is equal to ax plus b, which is just going to be a line, right? And b is my y-intercept. And notice as I shift it down or up, it shifts my graph down or up, yeah? And what does a do? What term is that in my linear equation here?
Slope.
That's the slope. So as I tune the slope up, the graph becomes more tilted. As I tune the slope down, it becomes flatter. And as I switch to negative, it gets to negative numbers. This is the best part about Desmos, is the fact that you can see what different constants do in different equations. Let me show y'all a really spicy one, and then we'll do the warm-up question. Okay, so it's going to be x minus h, quantity squared, divided by a plus y minus k, quantity squared, divided by b. And all of this is equal to r. And I'm going to go ahead and I'm going to give a slider for each one of these. This very fancy equation is the generalized equation for all circles and ellipses. So check this out. It's starting off as a circle centered at 1, 1 with a radius 1. But by using h and k, I can shift this circle wherever I want. This goes left and right. K goes up and down. R changes the total size. And A and B will let me stretch it independently in both directions. So if you are trying to figure out, like, hey, I need an equation of an ellipse to behave in a certain way, you can feed it into Desmos and play with the sliders until it looks exactly how you need it to look. And then you can read what these values are directly from the graph.
How do you do a fraction on here?
You type in slash.
Oh, I'm doing it on my phone, so it's not giving me a keyboard.
Yeah, you'll have to tap down below and see on my screen how when I click this, it pops up with show keyboard. If you click that in the app, it'll give you all the fancy math commands that you don't have regular buttons for. Like, for example, if you wanted to use pi as a digit, pi is here.
Oh, okay.
Great question. Are there any questions on using Desmos?
No.
Tight. Yeah, Desmos is fire. This is like the best way to graph, period. It's way cooler than one of these old school graphing calculators. Don't get me wrong, you have to learn how to use these guys for testing. But if you're just doing homework, or more importantly, if you're just trying to learn, if you're just like, oh, Mr. Rob showed me this crazy ellipse equation, what do the letters do? This is the best way to learn what different letters do in different graphs. But yo, we're doing it boring. We're just using it to graph points. So literally all I'm gonna do is I'm gonna type the points in. The only reason I'm showing you this is so that you have a new skill and so that the graph is actually nice and pretty instead of being all chunky like when I draw it by hand. So this is just gonna be the point -3, 5. You'll literally just type the points in and it'll display them on the graph. And we can also add a label to it in case I wanted to give it a name like A or whatever. And then 3, 7. Oh yeah, or if I just, leave no label on there, but leave the label switched on, then it'll label it with the digits. 0, -4. And then 6, -2. Is this okay?
Yeah.
Yeah, pretty clear that this forms a rectangle. And by how much were we going to reduce this rectangle?
Is it by 1/3? 1/3.
By 1/3. So we're going to go through and we are going to hit every single one of these coordinates with a factor of 1/3. And I'm going to color code them. So this first one is going to be -3 divided by 3 gives me -1. And then 5 divided by 3. So there is my first reduced coordinate. And if you hold the button down, you can match it up by color. So I'll be color coding these. We'll be giving that guy a label. Gotta turn it back on, that point, okay. And then the next one, we'll reduce that red coordinate. So it'll be 1, 7/3. Give it a label. Make it match the color, great. And then we are going to reduce down blue. What's 0 divided by 3?
0.
Undefined.
0, comma, -4 divided by 3. So there's our reduced blue coordinate, blue. I'll give it a label. And then finally, I'm going to reduce down the green coordinate. 6 divided by 3 is?
2.
2.
Comma, -2 divided by 3. Parentheses, give that guy a label. And then I'm going to have its color match as well. And we can see here how this bigger rectangle, right, has been reduced down to 1/3 of its size by bringing these coordinates all closer to 0, 0 by a factor of 1/3.
It looks so cool on this.
Yeah, Desmos is great. It's still my favorite graphing software. Like, even though I'm an 18th grader now, I still use it when I'm doing my own homework, because if you're just trying to figure out a graph real quick, this is the best tool. And it's still crazy to me that it's free, man.
It's like neat.
Yeah, it's the wildest thing that Desmos is free for anybody to use. No credit card, no nothing. You can even save this stuff to your own account. So if I hit save right now, because I'm logged in as myself, if you hit save, I could call this geometry warm-up 3/26/2020 and hit save. And once you've done that, you can actually just grab this link and send it to your homies in case you ever need to share a graph that you made with somebody. Is that okay?
I'll set that up today.
Okay. And so let's go ahead and do the distance formula now to show that whatever the length this is reduced down to 1/3 down here. And for this, you can use any pairing of sides, but I'm just going to happen to use the top sides. So I'm going to go from -3/5 to 3/7 and -1 and 5/3 to 1 and 7/3. Mostly because I want to talk about how we square fractions in case y'all have forgot. Okay, so let's do the distance formula between these two first. So this distance is going to be equal to the square root of -3 minus 3 quantity squared plus quantity 5 minus 7 quantity squared. Is that okay? So it's x minus x plus y minus y squared. And now I'm going to square this. What is this number squared?
36.
Plus, what is this number squared?
And then one
4.
other update is you'll have
9.
So this is equal to square root of 40. And let's go ahead and play the simplification game just because it's important practice. Give me some factors in 40.
2.
4 and 10.
I like 4 and 10. And this is mostly due to the fact that 10 has factors of 2 and 5.
Then it 2 and
4
10.
has factors of 2 and 2. So what can I pull out as a pair?
2.
2. I can pull these guys out, and then these guys are stuck inside.
Multiply together.
So this is
Yeah, 2
equal
and 10.
to 2
2 root 10.
root 10. Okay, and now we're going to do the exact same thing, but for our reduced coordinates. And so for our reduced coordinates, we are going to do the distance formula from here to here. So it'll be from -1 and 5/3 to 1 and 7/3. So here's what that looks like inside of our setup. So the second distance here is going to be equal to the square root of, what are those x values?
-1 and 1.
-1 minus 1 quantity squared plus, what are the y values?
5/3 and 7/3.
5/3 minus 7/3 quantity squared. And from here, the rest is math. So here on the inside, I'm sorry, let me give it a distance 1 and a distance 2. So distance 2 over here is going to be equal to the square root of, what's 1 minus 1 squared?
4.
4. And then what's 5/3 minus 7/3?
-2/3.
So this is -2/3. So what's 2 squared?
4.
And then what's 3 squared?
9.
When we square a fraction, keep in mind that we square the numerator and the denominator independently. Now, in order to add these, I'm going to have to come up with a common denominator. This denominator is 9, so I'm going to have to take this 4 and I'm going to multiply it by 9/9. The point of doing that is that 9/9 is equal to 1, so it's not actually going to change the value. It's just going to make it so that I can add these two. So this is going to be equal to the square root of 36/9 plus 4/9. And what's 36 plus 4?
40.
Equals the square root of 40/9. And so let's go ahead and take the square root of the denominator. What's the square root of 9?
3.
So this is equal to 1/3 root 40, which I guess that does it, huh?
Shows, yeah. It shows
Wait, how's it 1/3 and not 3?
It's the
Because it's
square
1
root of 1/9, and the 9 remains in the denominator, so the 3 remains in the denominator.
Oh, okay.
So this is telling us that this length is 1/3 times root 40, And our other length was root 40. So what's the scale factor from here to here?
4.
1/3.
1/3. From here to here, we are multiplying by 1/3, which is the exact factor we use to reduce the coordinates themselves. Keep in mind, whatever number you use to reduce those coordinates will always be the same number for the scale factor. So that's about it for today and kind of for the chapter. So let me tell y'all a little bit about what's going on before we head out to spring break. I haven't graded your quizzes yet. I only have the multiple choice part graded. I'm going to just post the answer key to the take-home part so that y'all can look over it and see how you did. So I'm going to grade and enter those either this afternoon or tomorrow afternoon. I've been really busy with my own homework because since all of my classes also got moved online and one of them was a lab course, the guy who runs my lab course decided to hit us hard with homework. So once I get that stuff done and uploaded, because my school's spring break technically starts on Monday and this assignment is due before spring break starts, so I have to turn it in on Saturday. I'm finally getting caught up and I will be able to grade and enter your guys' work. Next week on Wednesday, the last day of school before we head out to spring break, we'll have a chapter test. So next week on Monday and Tuesday, we're just gonna hang out, do review, answer your questions about the chapter. And then you'll have a chapter test on Wednesday, which is of a similar form. It'll start off with a Google quiz part and then a free response part. And then once you do that, y'all are free to go on spring break all the way until April 14th, which is a Tuesday.
It's funny how heading out to spring break is just staying